Yeah. To the instantiation of this member function, even though it is static, is still using opt t, which can be either, well, sum product or exponentiation. And it needs then the definition of the whole class. That is, it calls getOpt, which creates opt. But by that time it must exist. So I have to move this below this header, otherwise exponentiation doesn't exist apparently. Okay, now it exists, but it is still abstract. All the virtual functions must be defined. Virtual functions. Well, let's begin with maybe not the best thing to do to look at this file. Let's look at one that has been implemented already. Sum. So then we have something with override. I'm going to begin with printing it. If that does not already exist, that does not exist. Print, well, exponentiation. Not worrying about the superfluous parentheses yet. Let's print exponentiation like that. Type. Does this thing already exist? Yep. That's a lot of them though. No, that's correct. Okay, so next we have an evaluate. It comes below the type. So must be CMOV. And then I have, is that all? What, differentiate? No, maybe that's all. At least for the virtual functions. Still have a constructor here. Already have a constructor. Sort of. Doesn't seem to be defined though. Let's add a differentiation. I have to add that apparently to CXX file. Let's just write everything and then edit this again, but now for the CXX file. So we can again steal from the sum. Differentiate. Partial differentiation with respect to symbol. Let me see, so we have argument 1 to the power argument 2, but argument 2 is known to be a constant. So differentiate of argument 2 is going to be 0. You can use that, so I don't use that, don't need this. So x to the power some constant. Oops. If you differentiate that with respect to, oh, it's actually a function. Huh? It's a function of x. Same. Hey, Ghost Monk. So the dx, but then the round, not, yeah, round d, but I don't have that handy now. Now first you pretend that you take the derivative relative to f. Which I think is just c times the f of x to the power c minus 1. And then all must be multiplied with the derivative of f itself, correct? I'm wondering if c can be 0 or 1 or something like that. I don't think so. Should have done that here. I don't think I want to be using exponentiation like ever. Where's my constructor? Oh, here. Well, I do have those things. Oh, a search. Arg2 must be a constant. Yeah, I'm not testing that it cannot be 0 or something. No, it can never be 0. It should never be 0. Don't use exponentiation when arc2 is 0 or 1. Not. Is I have an is 0. Static also, constant. So we can safely subtract 1. That's not going to result, well actually it might result in 1 of course, if c is 2. So we'll have to check that. Okay, let's calculate the new exponent. I wish I could, there was a way to do that simpler. In the end you would say I just can do new exponent is old exponent minus 1. Oh, that would be cool. Yeah, I don't think I can do that though. I should definitely be able to do constant cached 1. But then we must be sure that 1 already exists, we're just not sure here. It starts to be a problem. Oh, these are statics, they are already. They're always defined, even before we enter main. So I can just use that, yep, totally. Yeah, they would be very involved, like subtracting is doesn't exist, so it is first going to be converted to plus the product of -1 times 1, and yeah, so I might as well introduce my -1 right here. But let's speed this up a little bit, I think. It really feels stupid to do that through the cache. Yeah. Let's make this work. And I need to add an exponent. As an accessor. Well, when I call this exponent? Well, it was about the static cost. I might as well add a base, although that doesn't do anything then. Just return argument 1. And then this is constant, so this is a constant, which I didn't define that yet. Let's add a -1. Need to define a plus operator for the constant. Do I already have constant here included? Yep. So now let's just go to constants. I have to sneeze. Is it going to happen? What do you think? No, maybe not. Yeah, let's make it a friend or guess somewhere. Okay, argument 1, numerator. I'll have to multiply that with the denominator of the second one. And then I can add argument 2 denominator times argument 1 denominator. Divided by argument 1 denominator times argument 2 denominator. Yep, so so the new exponent is 1, then we don't need to do an exponentiation. I just need to do multiplication of the old exponent with the old base. I'm not sure I want to call exponent again, or do I? Just cost. No, that's good enough. Exponent, comma, base. Then we have this part. And all that must be multiplied again with the derivative. Derivative of the base. This is kind of argument 1. Yeah, maybe I should just use argument 1 there. Hell, I'm going to use argument 2 here. The coughing is back. If the new exponent is not 1, no, it's not going to be 0. C is also not 1 or 0, so I always have to multiply with it. I just get the exact same thing, except that I must make an exponentiation, which already takes care of the zeros stuff, but it's not never 0 or 1 like I just said. So I can just use the realize here. So in principle, I get the same thing, except that, or I just used base, which was argument 1 here. Now I need to realize of the base to the power new exponent. Not even sure I want to keep the comment. No. Now let's remove some code duplication actually. I'm going to do expression constant reference new power is, and then it depends on this. If the exponent is 1, the exponent is not 1, this is the answer. Kind of makes sense, doesn't it? Yeah, that's almost the job of make exponentiation. So maybe I should just call make exponentiation with the new exponent as arg2. That then also tests for 0, but who cares? And then I only have a new exponent once, so I might as well put that here. Yeah, where arc2 is basically the exponent. Maybe it reads better. I just type exponent here as well. Same assembly code, but multiply exponent with make exponentiation of the base to the power exponent minus 1, all multiplied with the current base differentiated by symbol. No. I'm not feeling super happy about having to call exponent here instead of using argument 2. The only reason I do is because I know it's a constant. An exponent then returns a constant, which then uses an overload of operator plus, which is faster than a general addition, which would return the same thing, but it's just way slower. Would first have to figure out that it is a constant. No. Yeah, why wouldn't it know about that? Still, it's an expression. What? Yeah, this is the one that I want to call. Just constant plus constant. Oh, guess is guess minus 1 stored as an expression. Actually it is. Maybe we should make those things constants. I mean, they are constants. Why not use it to make C tags? And then I'm gonna go to the edge. They are constant, but I've typed expression here. Okay. Because this still works. And then I have to cast it. Get constant. Yeah, maybe I should call realize then. It's the exact same thing with get, but then casting it to a constant. Yeah, static. Why not? Let's call realize. Constant realize. Yeah, this is pretty dirty coding here. I hate globals. And these are as global as they get, and they do a lot. Not good. Don't like it at all. But a little voice in my head says that it will work. But yeah, normally I would never do this. I just do it because what is the word? Anyway, this is global. So before we even reach main, it's now going to call this realize, which is doing a lot of shit. That is, it's calling get on expression, which is calling emplace on a standard ordered something, which is called new. So we call allocate to be for main. Well, not too bad, but it's going to construct an object. That's not necessarily a problem. New, that's only a problem for libcwd, but it can deal with it just fine. Emplace in the database of yeah, well, it could be a problem with, let me think. Yeah, in this specific case, it's just not a problem. It's not a problem. And normally, I really stay far away from globals. See, the problem is that those references are going to be references to objects added to this standard unordered set. No, well, not really, to the expressions that the unique pointers in the standard unordered set are pointing to. Thus, they are going to point to invalidated memory as soon as this database is destroyed, which in itself is a static. There we have it. So now I must make sure that the S database is actually constructed before the other statics, which of course is totally not guaranteed at all. The famous static initialization order fiasco. And then I was thinking about destruction a moment ago, but that might not be that problematic. I think that once we leave main, it should be assumed that nothing is really dereferenced anymore. So it doesn't really matter that I destroy the database first. No calculation should happen with expressions anymore at that point. But yeah, it would be bad if I do try to call realize on those three constants before the database wasn't even instantiated. However, this thing is part of, actually no, it's part of the base class of the constant, but I don't think that guarantees any order. So there you go. It is a problem. Yeah, I'm using static all over the place. Well, this is not a problem, but the static member variables are a problem. How many static variables do I have? Database is really, really bad idea. Let's see how many I have of those. I have these. Which of these functions? Yeah, it seems that those are the only 4 that I have. But I need to guarantee that my database is constructed before these. Um, everything compiles. Can only raise expressions to constant powers. Wow. And I didn't do that. It seems extremely unlikely. Hi, Lens. What is going on? GDB run up. It's not a constant arc2 in place. There's exponentiation. Arc2. Shit. I completely misunderstood my own naming here. Exponentiation means arg1 and arg2 are the same kind of symbol, same kind of expression, and I have to treat them both as a base, add their exponents. So I misuse this thing. I didn't really misuse it because it's doing what I thought it would do, or not. Yeah. I implemented it wrong as well, apparently. Confusing. This is indeed making the exponentiation, or argument 1 is the base and argument 2 is the exponent. Let's give them the right name, therefore. With this base and this exponent. Assert the base is not a constant. If the exponent is 0, return 1. And here I was paranoid, so it's not necessary. I can just use cached 1. And if argument 2, well, now called exponent, is 1, then just return the base to the power 1. Otherwise, you really have an exponentiation. And that thing I can call here, that is correct. But I'm calling it also from somewhere else, and then really I had expected it to do something else than this. Calling it from product. What the hell? Struct make exponentiation. That's symbolic, not symbolic 2. I'm going to have a look though what it did under that name. Yeah, that does something completely different. Oh boy. Going to rename it, I think. The other meaning, well, this meaning, but here. So I have maybe the combine is what it is. I do have a combine in the binding operator. See, I don't. It's yeah, I can add a combine here and then use that instead of the make exponentiation. Yeah, that's the different meaning of it everywhere. So let's rename this to combine. I have a combine already, which is for sum, and only for sum. Yeah, what about product? I mean, maybe I should just do product here, product combine. So product itself has a combine, which is strangely enough not used then. What is that one doing? Not implemented. Oh, okay. That's strange. Wait a minute. Really? Product has a combine below multiply. Let's look for that one. Multiply in symbolic 2. This one. And there's nothing below it. Make product. Nope. I think that's what I should have done or something. Yeah, probably right. So I'm going to call this thing product combine. And I think I were inside product to begin with here. So just combine will do. And nobody knows why I'm having product all over the place. Or maybe I thought it was better readable. Product. Holy moly. No, it's kind of silly. Yeah. Let's at the very least substitute product multiply with just multiply. Do we still have products? No, well, that were all of them. Okay, so the combine here. Let's replace that then with combine. Oh, what am I doing? Substitute that with combine. 3. Yep. And then I still have to implement that. So now that's product combine. You could put it below it, maybe, or yeah, maybe above it. Let's put it above it. It's kind of used before. I mean, it's used by the one below it, so this way it has a chance to inline it. It compiles, and then if I run it again, it wants me to implement it. Okay, so this combine is for when argument 1 and argument 2 are exponentiations of the same expression. And then I just have to add the exponents of both. But they might be just an expression to the power 1, aka just an expression. So I'm going to use something like a function that extracts the base part of it, like get base. It already exists. So get base is part of expression, the base class. So we can call argument 1 get base. Yeah, and these two must be equal then. Exactly equal. Assert. How do you test that? Well, I have all my expressions in a cache, so I think that they must be equal by pointer. It's kind of dirty, but and then we calculate the sum of the exponents, and then in the end I'm going to return a make exponentiation. Which was defined in exponentiation. Get any base, new exponent, or I can just add the exponent of both. So maybe I should have something like arg1 get exponent plus arg2 dot get exponent. And then make exponentiation deals with if that sum is 0 or 1. No, do I have a get exponent? No, I don't. Well, it's green, but it exists in symbolic, not in symbolic 2. Maybe I should just add it. Why did I add a get base and not a get exponent at the same time? Very confusing. Oh, because I didn't have exponentiation defined yet? No. Does get base even exist for exponentiation? I have the feeling that I didn't. So it's defined here, or is it just returning whatever the expression is? And yeah, that's exactly what I thought. Of course, this is expression.h, so there is no way I can access constant here. Majorly annoying. So by default it just returns 1. And then I have to define this in exponentiation. Symbolic 2, exponentiation. Oh, no, I just added that, yeah. Why did I not just call it get base? Hey, and make it in a Wordle function? Nah. These are not vertical. Very confusing stuff. At the very least, I need a get exponents, Wordle function, override, final, which then just returns the exponents. Okay, let's move it down and return get the exponents. And the same thing with the get base, I suppose. Operation get base, override final. Yeah, if I have the exponentiation type and I call base on it, I might as well call get base because it's listed as final. Which means it's going to inline this instead of going through the Wordle table. There's absolutely no reason to do that. And then for the same reasons, I guess I might as well remove the whole exponents function as well. Get exponent is not marked override, not marked virtual. Totally should be. I didn't add it yet, I think. Binding operator, so let's put it below get base. I'm having a get exponent here, which is virtual. What is wrong then? Virtual. Excuse me, that's exactly the same. Exactly the same. Expression. Oh, this is expression. Yeah, doesn't know what constant is. But why do I have that error there and not here? So for declare constant. Yeah. Yep, that is more like the expected error. So now you call get exponent, while in exponentiation it's going to see that this is a final override, and therefore it just goes to inline it. It will inline it. I'm lazy. Let's the compiler tell me where it is. There's the other one. I could have seen it, but yeah, like I said, extremely lazy. Make, compile, everything compiles. Let's crash. Da, 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 da. Job interview. What do you do when your program does not have compile errors? Well, hoping for an assert. And what do you do when your program doesn't have compile errors and it does not have an assert? Well, then I go home. I wouldn't know what else to do. No, it does a sum combine. Seriously. As if I have implemented the combine of the products. Yeah, come on, I didn't. Did I? No. Combine. It's totally, I just implemented it. Wow. Pretty cool. We are almost there, as it were. At least that's even the last fix me that I have. Getting excited. Okay, so combining two arguments, which should have then this be the same apart from a constant factor. So I need something like get non-constant factor. Get, actually now my E also broken. Get non-constant vector. Does get a core, but I doubt it. That is again symbolic. This is symbolic too. Oh, we have it as well. I even implemented it. Awesome. Well, this is definitely an expression. So I'm gonna get a non-constant vector called vector 1 maybe. Yep, and then we also need to extract a constant vector itself. How did I do that in the auto combine? Even though, no, I didn't. I didn't until we don't see make a C text. I mean, combine, product combine, just bang. Okay, get exponents and then add them. Yep. So I need the get. Yeah, that's of course it is again a constant that we can add. Get constant vector or something. So I want to return. There's going to be multiplication, right? Product. Multiply. A constant with the common factor, and the constant here is then argument 1 get constant factor plus argument 2 dot get constant factor. Okay, did we implement this on get constant vector? Nope, didn't. This is in some namespace symbolic. Well, that has to be defined somewhere closer to that one, I suppose. Yeah, that thing also has a default, namely returning 1. So it is kind of the same as the get exponent thing. By default. Where's my fix me? Could have typed it. That was impossible that it was that long ago. Oh yeah, let's do a normal core dump. Who needs a search? Don't like that. Why the hell would it core dump in a dynamic cast? That doesn't make any sense. think we have memory corruption because there's no way. Why? Yeah, it could be deleted or something. Maybe it's deleted memory, but it isn't because it exists here still. So yeah, I don't know. Oh, you have no idea why it's quoting this. Stack Overflow. So a recursive call, I guess. Just keeps calling itself, never ends. That should never happen. Then maybe should have done a backtrace and try the GDB again. Totally Stack Overflow. Yeah, so apparently some combine calls plus, which calls add, which combine, and so on. No, it would have been nice to see where it entered first. I don't think we can do that, it's just too much. But you never know. How big is this stack? I'm just going to do C. I have a huge stack. Go to your room. Don't do that. Oh, sorry. My God, this is super long. Ah, there we are. Main, of course. Oh, yeah. I think this one's new. And then 2 adds, also new. Guess the entry point is this. Just put a breakpoint here. Really? Just put a breakpoint there, man. What is it doing? And then after we get there, I want to have a breakpoint at some 50. Okay, it takes so long. What is it doing? Nothing. It just waited for some reason on my return. No scrolling my ass. So run again from the beginning. Yes, thank you very much. Printing S times S. Nothing. Why? Just making bullshit. Oh, I have to flush it. Yeah, now we get output. So argument 1 is x times y. I guess S stands for sum, is x plus y. Multiplying that would have an x times y in it somewhere. Okay, same thing for arg2. X times y. So that should mean that the pointers are both are the same, because I cache everything. Can only have one each expression once. So just the same expression. X times y. And I'm going to do 50, combine those two, which then results in 2 times that expression. Yeah, well, makes sense. Step. The non-constant vector should be the same thing. So that's just the same pointer. Yep. And obviously the vector 2 as well. Then get constant vectors would return 1. I can just print that already, probably. Print argument 1, get constant vector, which is this. And the term should be equal to constant as cached 1. Yep, it is the same. So now I get a call to sum. No, we get a call plus. Oh, get constant vector is not returning a const maybe. And a minute. No, it's returning an expression const reference. That is the problem. Get constant vector should of course return a constant. Mm. Also dubious here. So I'm using, I'm dereferencing the virtual table by calling is constant, which calls type, which is a virtual function. I'm not sure. I might as well do a dynamic cast. That's my idea. To just try to cast it to a constant. So that like probably even faster than dereferencing virtual table. It's just comparing the virtual table entry with a constant. So yeah, must be faster. And then I already have the const reference, or at least then I have the const pointer, because I must do it as a, yeah, I'm gonna do that. So keyboard is dropping down all the time. I need a longer piece of metal for that thing. Okay, so what are we going to do as a const pointer constant vector is dynamic casts of the pointer to argument 1, and then I can replace this with just is that non-zero, and if it is non-zero I can just return a reference to it. Constant vector. No. And now mysteriously my crash is gone. Everything works. It's printing -1 like that. But well, these are formulas that we never saw before. X plus y times x plus y. I think there's missing parentheses there. Ouch. Should have been x plus y times x plus y. And then we get x times x squared plus. Now we have too many parentheses. Y squared plus 2 times x times y. That's nice that it did combine this. Yeah, I should put it to decimal again before I print this. So I'm having a standard hex somewhere. And that is kind of sticky. Maybe this one. So. That's the -1. And I'm starting to feel like I want to fix those parentheses everywhere. It's kind of horrible. The printing of parentheses or not. To print or not to print, that is the question. That is a difficult question. It keeps haunting me. Let's try to differentiate this thing just for fun. And for now I want to print a parenthesis around this as well, but I think I'm printed it manually, so I just have to add manually those parentheses. Manually being right here. So you have to print, just use that. Is. And then I want to do the same as everywhere else, being test differentiate. S times S. Partial differentiation of S times X with respect to X. And that would be this. Completely unreadable, but 2 times X plus 2 times Y. I'm not sure about that. Don't tell me they went wrong. It's no longer compile time now. I have to edit the title of mine. I'm working on runtime differentiation. So yeah, we have this formula, which is really not readable at all, but okay. Where's my equal sign? So this formula, let me translate that. So remove some stuff. This is obviously just X times Y times 2. And this is Y to the power 2, and this is X is no parentheses needed whatsoever. And then I want to take the partial derivative with respect to X, and I would say that gives me 2X for this. That gives 0, and this gives 2Y. Oh, fuck, it is correct. Yeah, so that worked. Partial derivative with respect to X of that same thing is 2X plus 2Y. So, yes. I think I'm going to have a break, go for a walk. And then afterwards I have to implement stuff like division and subtraction, which is quite minimal because I just implement those in terms of the things that I already have. And yeah, I really have to face removing those parentheses. It's just ugly. It's unreadable. Maybe you can think about it while walking. It's going to be a